So we're going to start off on page 7 of your packet. So this is the absolute value functions practice. So number 1, it says to graph f of x equals 2 times the absolute value of x plus 3. And it says to include a table of values. Well, I know that my vertex is going to be negative 3, 0, because this plus 3 tells me that the graph, the parent function, absolute value of x, which would normally look like this, is shifted 3 over to the left. So I'm going to make sure that I include negative 3. And so then let's do 2 on each side. So you want to include about 5 points to get an accurate graph. So we have the x values, so we want to find the y values, so we use the given rule to calculate our y values. So y equals 2 times negative 5 plus 3, and so y will be 4. Y equals 2 times negative 4 plus 3, so y will be equal to 2. Y equals 2 times negative 3 plus 3, which will give us 0. So then this is negative 2 plus 3, which is positive 1 times 2. And y equals 2 times negative 1 plus 3. Remember, absolute values, if you get a negative value, it's going to turn into a positive. So that's 2 times 2, which is 4. So now I can use these points to graph. So I know that my vertex is at negative 3, 0. Then negative 2, 2. And negative 1, 4. And then likewise on the other side. And we can graph this like so. Okay, so the equation of the axis of symmetry, I'm looking down below. So remember, the axis of symmetry is the vertical line that splits your graph into 2 symmetric pieces. So I can see right here that this is going to be my axis of symmetry. So this is a vertical line. So this is x is equal to negative 3. Again, it passes through the vertex. And the coordinate of the vertex is negative 3, 0. So what is the domain? Domain is all the x values that you can plug in. You can plug in any x value you want. So it's negative infinity to positive infinity, because it's any value along the x-axis you can plug in and get a value for. The range is all of the values that you get from the function. So if we look, I get all my y values start at 0 and go up to infinity. So it's going to be 0 to infinity, and we include the 0 because there's a point on the x-axis. And the x and y intercepts. So the x-intercept is negative 3, 0. So where does it cross the y-axis? Well, we could estimate, or we could use our function. So when it crosses the y-axis, we know that x is equal to 0. So if I say y equals 2 times 0 plus 3, I get that y is equal to 6. So it's at 0, 6, which looks about right. This looks like it should be 0, 6, but if you wanted to make sure, you could plug it in just to double check. Okay? So the next question is asking you to describe the transformation of each absolute value function compared to f of x equals absolute value of x. So this is our parent function right here. So this is what we're comparing everything to. And you can bring everything back to what we talked about with quadratic functions. The same sort of effects that you see with different h and k values, you're going to see here as well. So g of x equals the absolute value of x minus 7. So this is outside, so this is a change minus k. So this is shift down 7 units. Because this is a change in the k value and it's negative. Here we have x plus 5, so this is a plus h. And remember, with h, it's going to be the opposite of what you think. So this is going to be a shift left 5 units. Okay. Here we're multiplying by a, and a is greater than 1. So this is a vertical stretch of a factor of 3. And here we have two things going on. We have a vertical stretch and a translation up. So we have vertical stretch, a factor 2, and shift up 1 unit.